All right, guys. So last part of chapter 4. Okay, guys, we're getting started. Thanks. So we're solving trig equations, and we're going to do a lot of trig equations in the next year. So chapter 5 is going to be more trig. We're going to do a lot of verifying identities, and we're going to do hard identities because you guys are pretty comfortable with trig by now. So we're going to really kind of ramp things up as we move through the semester. But something very simple, like if you're told a equals the inverse sine of root 3 over 2, you want to see what angle that would happen at. That would happen at pi over 3, right? So, that's what we would say, pi over 3. And remember, there's a default range for this. And what was the default range for inverse sine? Right, inclusive. Now, this one here is kind of interesting. Because here you actually have to find all values of v that satisfy the equation. So when you work this out, if you think about it, definitely pi over 3 still works, right? But what else would work too? And then 7 pi over 3. Yes, exactly. 8 pi over 3. Or I can go backwards, like negative 5 pi over 3. Negative 4 pi over 3. There's a whole bunch of options. So here's what you'd want to do to express your answer. So we call it the general solution. There's a few ways you could write. I tend to prefer this. Pi over 3 plus 2 pi k. And 2 pi over 3 plus 2 pi k. Where k is any integer. K can be any integer. Therefore, you can go backwards too, right? Or forward. So that's how I prefer to write it. Now, sometimes you might be given a specific domain. Like, hey, give this from 0 to 2 pi, where 0 is included and 2 pi is not included. Then you just give pi over 3 and 2 pi over 3. Or I could be real hard ass and say, well, give me the answers for the domain from like negative 6 pi, negative 4 pi. I can do that. So there's a lot of ways you could ask this question. But if you don't see a specific domain, the assumption is the best. But this is just straight up. Yeah, I want my answer. How come I don't get multiple answers to this? Why would I get multiple answers to this and not to this? Yeah, so I want a function. I want this to be a function, right? I want this to be a function, you want outputs. So here, I want to see all possibilities for an equation. Yeah. So, question, Audie, go ahead.
So then for sine, it's plus 2 pi k, but for tan, it's plus pi k.
Exactly right. Yes, 100% right. So let's do an example now. And here you're asked by the general solution, the first 3 positive solutions. So that should be really easy, right? Cosine x equals root 3 over 2. What's the first answer that comes to mind? Pi over 6. And by the way, I do want radians. So degrees I won't accept because it just gets, well, you need to get used to radians anyway, but it just gets kind of weird with the degrees. So pi over 6 for sure. Where else will it happen? Good. And where else? Good. So those are your first 3 positive solutions. Then the general solution, are you good? No, are you had a question? No. Okay. So pi over 6 plus 2 pi k, and Brooke, go ahead.
Oh, question. Would there be a difference between like writing negative pi over 6 plus 2 pi k or 11 pi over 6 plus 2 pi k, or would those just be the same terms?
Those are the same thing.
Okay.
Yeah, those are the same thing.
Can you just write 2 pi k plus 2?
No, because it won't lead to 11 pi over 6 then. Oh, actually, would it? Would it?
Yeah.
Oh, it would. Oh, yeah. So I'm kind of redundant here, because it's a Wait, would that? Hold on one sec.
I was thinking that 13 over 6 would be redundant.
No, that for sure. But for 11 pi over 6,
That's not redundant.
oh no, it's not redundant at all. No, it's not, because no, it's an even function, but No, you have to write two separate answers. You're saying to combine these two?
Are you saying plus or minus?
Plus minus over here.
Plus or minus five or six.
You don't have to write plus or minus, your K could be negative.
Why would you do that? Negative power
I mean,
six.
no, I understand what you're saying. That was every single one. No.
Oh, you're saying this. Is that what you're saying? Oh, I get you now. Yeah, you could. Yeah. Okay. Actually, okay, so now I know what you're talking about. I was a little confused. So what you were suggesting, if you did this, would that be valid? It would, because it's an even function. Yeah, so that would be valid if you did that. But just be on the safe side, because that's a rare case. Just take the solutions from the first rotation of the unit circle and then do plus 2 pi k. That's to be on the safe side. Take all the answers in the first rotation of the unit circle, then do plus 2 pi k. Or if it's tangent, plus pi k. All right, let's try it again. Now we want the first three negative solutions. So sine 3x. That's interesting. This gets really interesting. So you get root 2 over 2. Now, before we get carried away, what does 3x equal? 3x equals what? Pi over 4. Oh, it's negative, right. Sorry, my bad. My apologies. So it'd be 3 pi over 4. No, lied again. 5 pi over 4. Or what's the other one? 7 pi over 4. Okay. So in this case, x will equal 5 pi over 12. Or x could equal 7 pi over 12. Okay. But you have to be a little careful here. Before I give the general solution, let's do the negative solutions. So what if I went backwards? So 3x could equal negative pi over 4, right? Would you guys agree? So x could equal negative pi over 12. Or can 3x equal negative 3 pi over 4? So what would x equal in this case? Negative pi over 4, right? And then if I went backwards one more time, I have to negative 9 pi over 4, good. What would I get? Negative 3 pi over 4? Okay. All right, so what I'm noticing, go ahead, Carl, yeah.
If you wrote negative 3 pi over 12, and because that's not the solution, that'd be wrong.
That's fine. Sorry about it. It's all good. Okay. So here's the deal. We noticed that this is in the third quadrant. This is Q3. And well, actually, technically, that's Q1. That was Q3 right here. And that was Q4. But then, of course, things change, right? So what are you noticing is a difference between consecutive, like, I'm not gonna write plus 2 pi k. That's not gonna work, guys. What should you do instead? I'm not gonna write plus 2 pi k. What should I be doing instead?
I don't know.
Yes, yes. And you divide 3. That's your general solution, guys. So you can't write plus 2 pi k. You have to write plus 2 pi k over 3. This technically here's what's happening. Your general solution truly is this. When I solve this part right, 3x equals 5 pi over 4 plus 2 pi k. That's truly the general solution. But then when I divide the 3, guess what? This gets divided by 3, and that gets divided by 3. So you do have to take the coefficient of x and put it below the 2 pi k to make this actually accurate. Plus the fact that 5 pi over 4 and negative pi over 12, that is going to differ. Sorry, I'm going to say 5 pi over 12, my bad. 5 pi over 12 and negative 5. What am I? No, sorry, I'm losing my mind. I meant to say this. Those differ by 2 pi over 3, right? Because they differ by 8 pi over 12. Likewise, a 7 pi over 12 and negative pi over 12 because those are both also in Q4. Those will also differ by 2 pi over 3 or 8 pi over 12. So yeah, so we have to be mindful about that, about the difference between each solution. Catherine, go ahead. No, I just felt like doing it just so I had an idea what's happening. Yeah, so actually I didn't really need to yeah, so what you could have done, right? You could have done this plus 2 oh geez, that's a terrible color. I could have done plus 2 pi k over 3. So is that what you're asking, Catherine? Like, yeah, that's totally fine. Yeah, you could do that also as your answer. That could work. Okay, questions? Nope. All right, well, let's keep on moving. All right, so let's look at example 3, 4. Okay, so why don't you guys try example 3? We'll check in about 2 minutes. I'll do it also.
Hey guys. What's time? Equals y. What's the other one in the 2 pi?
Yeah, sounds good, guys.
You're right. You say it again. So be right. And then no, it's not 4 pi. Yeah, it's 8 pi. Sorry, I don't trust you. Why? Thanks. Wow. Let me know what you guys get.
Exactly. Nice. 5 or 6.
Are you ready? You ready?
I don't have my general solution back then.
Pi of 24 times.
No, it's not. Well, it's not like pi over 20. I got power of 24.
5 pi over 20.
The power of 12 times.
Oh, I'm doing that memory.
I didn't plug each one in. I just I just multiplied by 2.
I got power over 24. 5 pi over 24.
We don't really have to. Yeah, but then you can.
The next one is gonna be. The next one is gonna be 8 pi over 22, right?
8 pi over
And 5 pi over 6.
5 pi over 24.
I don't
Over 5 pi over 24.
All right, you can go.
All right, here we go, guys. Here's what I got. Whoop.
Let me know if I screw you. I make mistakes.
I got 3 pi over 24.
We're okay. Yes.
Whoa, pi k over 2?
Okay.
That's where we went wrong.
Your coefficient of x is
I got
4.
negative.
So for a general solution, you have plus 2 pi k. You would have the plus 2 pi k after the 4x. 4x equals pi over 6 plus 2 pi k. We divide by 4, you know, pi over 24, and plus 2 pi k over 4 pi k over 2. And when I put this over here, 4x equals 5 pi over 6. That happens in the second quadrant. Sorry, 4 pi over 3 is where that's in the third quadrant. But you subtract it, work this out. So true, 4x equals 5 pi over 6 plus 2 pi k, but you divide by 4, you get 5 pi over 4 plus pi k over 2. And then if you were to use the general solution to get the third positive solution, by plugging k for 1, I should get pi over 24 plus pi over 2, pi over 6 equals pi over 24, add pi over 24, get 3 pi over 24.
So I think I did this right. And general solution should be correct. But please let me know if you disagree or questions. Go ahead.
For the plus 2 pi
Mhm.
k.
Yeah. pi k over 2. Or 1/2 pi k. Right. So you can do 1/2 pi k. That works. Do good.
So we don't like do the horizontal expectation for like the domestic 2 pi because it doesn't.
Right. Exactly. Right. We don't need to do that. Yeah. We're just undoing what's inside the parentheses. So yeah, Kate, go ahead.
I don't know what it sounds, but just for the period when you're adding on the period, you're not doing the 4x, you're not doing the et cetera.
Right. Right. Okay, we're good. Cool. All right. Yeah, so this one, again, just be careful. When you see a coefficient in front of x, that's not 1. 2 pi k is going to be divided by that number as well. That's part of the general solution.
But you don't subtract pi over 2.
Right.
Yeah, probably do subtract.
I didn't.
Wait, Oliver, were you bringing it up?
So when you have 4x
Yep.
plus pi over 2 equals 2 pi over 3 plus 2 pi k. Oh, but when you subtract the
Well,
so you only subtract 1/3.
well, yeah, it's not a like term.
Yeah.
Because 2 pi k. All right. Solve this equals undefined. Okay, where's secant undefined? That's when cosine is 0, right?
So just cosine 3x over 2.
Right. So pi over 2. So no. So when the cosine of an angle is 0, that's what I meant to say. Yeah. Right. Sorry. That's what I meant. Sorry. So yes, this will be undefined.
So then you need 2 separate equations.
Right. So you're gonna have that happens at where again? At pi over 2 and oh no, I know that. Yeah. Right. So in this case, your general solution is going to be pi over 2. I see what you're saying. So yes, there are 2 areas where this happens on the first rotation unit circle, pi over 2 and 3 pi over 2. Now don't write this down because I could do this, right? And you would not be wrong. I would not. My K's look terrible. I'm so sorry. You would not be wrong if you did this, but it's a bit repetitive. It'd probably be better to actually consolidate that process and say pi over 2 plus pi k, because they're separated by 180, right? Yeah. So that'd be a general solution there. Oh, you're right. Sorry. Darn it. Okay.
Yeah.
Sorry. Yes, you guys are correct. Okay, let's back up. So yes, pi over 2 and 3 pi over 2 is where it happens. So 3x over 2. And actually it might be easier.
2 over 3x equals.
Yeah, you can say this. Okay, so then x would equal pi over 3. Or x would equal just pi, is that right? Okay. So if I were to do a negative solution, the third negative solution, I'd have to set 3x over 2 equal to what, guys? So if I go backwards, the first negative solution is negative pi over 2, negative 3 pi over 2. You have to equal to negative 5 pi over 2. If you want the third negative solution, which should be negative 5 pi over 3.
Where do you start from? Is this 2 separate equations?
So what you do is you go with the third negative solution. The first time that this experiences this situation, average negative 5 over 2.
Oh.
Then at negative 3 pi over 2. Then at negative 5 pi over 2. That's why I said it's equal to negative 5 pi over 2.
Instead of calculating the first and second negative, I went kind of direct straight to the third negative one. Right. And then in general, let's talk about the general solution. Go ahead.
Find the third negative solution. We're just figure out what that is. Like,
Yeah, because in this case, we know for sure it's going to be plus 2 pi k. But when we divide by 3/2 or multiply by 2/3, you get pi over 3 plus pi over k3. Is that right? Am I correct in? No, 4 pi, sorry, 4 pi. That's what I meant, right, there we go. Right. Or in this case, right here, plus 2 pi k, right?
Oh, yeah.
So if I multiply by 3/2 here, I get pi plus 4 pi k over 3. So those are your general solutions.
For the like the
And that's your third negative solution. There we go. Yep, go ahead.
What's the negative solution? Can I just, like, I know that it's gonna be. It's just secant.
Wait, I'm sorry, repeat that again?
If we're just solving for like secant of x.
Uh-huh.
Find the third negative solution, that's gonna be negative. By which next to that, I'm not gonna make opposite two.
Yes, that's what I did. Yeah, it's right there. Sir, yeah, that's what I did. Yeah, Audie, go ahead.
Shouldn't the third negative negative 5 2?
Well, sorry, say that again?
Shouldn't it be negative 5 2?
Yeah, but 3x over 2 equals that. So theta.
Yes, right. So theta, the third angle that makes this undefined. Sorry, the third time this becomes negative is negative 5. That's
Also, then the transformation is on.
right. Exactly. Then you got to divide by 3 as multiplied by 2/3. Pretty good.
Could we do that? Yeah, actually you could. So yes, so you're consolidating it. That works, sure. But I want to give you guys a way that's more universal to be on the safe side. But yeah, that works. So okay, so we're good. Okay, let's keep on moving. But yeah, you are correct, Brady. You could actually consolidate the process too and make it that. All right, let's try another one. Just 2 more problems. We're done with the unit. Yeah, you're gonna need a calculator for this one. So subtract the 3. That's easy. Okay. Okay, does that make sense? All right. Now, the first time you do it, it'll give you negative 0.7754, I think.
Yep.
So that's in Q3. Sorry, that's in Q4. But where else is that going to happen as well? In Q3 as well, right? So think about reference angles, right? If we think about reference angles, so right so this right here is negative 0.7754, right? So if you think about reference angles, you get the same thing here at positive 0.7754. Is that correct?
It's not so good in negative terms.
However, so this means that x plus 1, let me change colors. X plus 1 would also equal pi plus 0.7754. Because that's pi, right? And you're adding that reference angle to get the third quadrant angle. So actually, let me put that, I don't know why I put that.
Is this also about the institute science?
Right, exactly. Yes, that's correct. So
Again, that's what the calculator spits out. When it goes 4 quadrant, we'll go with that. But it's not the whole story, right? That also can happen in the third quadrant. So use the reference angle. That's negative 0.7754. You got to do 0.7754 the other direction as well. Oh no, because I'm just using reference angles. Because this angle here, I mean, technically speaking, you usually stays a positive angle. So you need the same over here.
That's the same.
like, for example, this was 30 degrees, then that would be 30 degrees is as well. Because remember that 210 would be 30 for the same sine, right? So it's the same thing. That if you have like actual number, like standard angles, but obviously it's 90 angles. So it's pi plus that. So you have to do that as well.
Which is 3.9170. 3.9170. So then when you work this out, x will equal negative 1 point, let's switch back to red. X will equal negative 1.7754. I'm going to put plus 2 pi k. And for this one, I'll subtract the 1, which will be 2.9170.
Yeah.
And then plus 2 pi k. So those are your general solutions. And I will not dare to consolidate that. I'll just leave it like that. And then for the second positive solution, really just kind of like look at it like, well, if I plug in 1 for k for the first one, that's positive. And of course, if I plug in 0 for k in this green one, that's also positive. So I probably would go with actually, wait 1 sec. What will be the first positive solution is going to be negative 1.7754 plus 2 pi. Is that right? Is that the second one? Wait. Yes. Because the first was 2.9170, right? That's your first positive solution. Yeah. So let's back up a little bit. Here we go. Let me be a little more organized here. Are you guys okay with the general solutions? We're okay with that. We're okay with the general solutions? Now, for the first, so where are the positive answers for this one, right? You get 4.5078 when k is 1. And when k is 2, you get 10.7910. Just trust me, I have my notes here. For this one, when k is 0, what do you get? 2.970. And when k is 1, what do you get? 9.2002. So the first positive solution is 2.970. The second positive solution is 4.5078. So that's your second positive solution.
So you would just do that plus 5.
Right. Exactly.
There's no bucket.
Yeah. So again, that's easy. That's just calculating work straight up. Do it. Plus 2 pi k done. But you gotta make another adjustment. We have to consider third quadrant. Use reference angles. Realize, oh, that equals pi plus that number. That part's a little tricky. This part here. Then once you get that's easy. Yeah, that. Then we find the second positive solution. Just calculate some positive solution for each case. You'll see the second positive solution 4.50 something.
All right, good. These are a little more dicey, these problems. I like it. Questions so far? Okay, we've got one more example. And you guys get a head start on homework. We got what time? 35? Okay. 35? 40? Okay.
Oh, we did notch it.
Okay, here we go. No, we got 35. Yeah, your watch is wrong.
Yeah, all right.
No, I was like, wait 1 sec.
Sorry, I was looking at that.
No worries. This is supposed to be the normal week. We haven't had this week in 4 weeks. So the schedule's like just got going crazy, right? Okay. So let's move on to the last problem. Okay, cool. Yeah, this is good. I like this one. All right. We have to write 2 equations, one involving cosecant, one involving secant to produce the graph on the right. Okay. So let's start with, and actually I'm going to throw you guys a little bit of a curveball here. We want A to be positive. Well, I don't say it's a curveball, but I'm just going to be a little more restrictive. Let's make A positive. And let's make H is non-negative. So those are the conditions I'm going to impose. Not a problem. Let's start with cosecant. So this is like a sine curve, right? The period is clearly 8. 2 pi over b equals 8. What is b going to be, guys? Excellent. Good. I agree. Pi over 4. What's the a value here? 2. Is there a k value?
No.
No, so 0. And there's no shift, right? So h is 0. So I've satisfied the conditions I set forth. I kept a positive. H is non-negative. So we're good. Now I just write it. And it's a cosecant. So y equals 2 CSC. You don't need a bracket necessarily. You can just do parentheses, pi over 4x. And that's it. Then what about secant? Okay. So you can think of secant like this. But it is shifted to the right. And shifted by how much to the right? So what's h in this case? 2. H is going to be 2. K is still 0, that doesn't change. A is still 2, doesn't change. Period is still 8, that doesn't change. So y will equal 2 secant bracket pi over 4 x minus 2. It is positive.
It is positive. I know, counter to.
Okay.
Oh, that's
Yeah.
that's
It's counterintuitive. Totally. All right, so we're all done. Very, very good. Guys, quiet, please. I got it. Guys. Try. Thanks. Go ahead, Brady.
Wait, what's he gonna? No, it's not. Sorry, it's not. Yeah, I got it.
Actually, thank you for that clarification, Brady, because I would hate for someone to think that. So pi x over 4. There we go. That's much better. Thank you, Brady, for clarifying that. Yeah. Okay, so we're done with the unit. It's been, lovely 7 days of just hardcore lecturing. But we're gonna do practice problems on Friday and Monday. Friday I'll have more details about tests. For now, if you guys want to get head start on homework and get it done, especially if you're gonna watch the Niners game tomorrow night, we'll see. If you don't want to do homework Thursday night,